All right, let's dive in. Today, we're going to unlock a kind of mathematical superpower. Seriously, it's a tool that helps you solve puzzles you see all around you every single day. Think construction sites or even just setting something up in your own living room. So let's kick things off with a little puzzle. It might look a bit tricky at first, but trust me, it's way easier than you think. Okay, so picture this. You've got a 40-foot ladder, and it's leaning up against a building that's 30 feet tall. Pretty straightforward, right? But how far is the bottom of that ladder from the base of the building? I mean, how would you even measure that without some crazy long tape measure? Well, stick with me, because by the end of this, you'll be able to figure this out. Maybe even just in your head.
Now, the solution here isn't some newfangled trick. Nope. It's actually an ancient secret. We're talking over 2,000 years old, and it's all hidden inside one of the most basic, fundamental shapes you could imagine.
So yeah, that's secret. It all comes down to one very special shape. And to really get the key that unlocks this whole puzzle, we've got to understand its different parts first.
And here it is, our hero shape, the right triangle. What makes it so special? Well, it's all about that one perfect corner, a perfect 90-degree angle. You know, just like the corner of a book or a box.
Okay, so the two sides that actually come together to make that 90-degree corner, we call those the legs. We're going to label them side A and side B. Think of them as the foundation of the whole triangle. And then you've got the hypotenuse. Now this one's easy to spot. It's always the longest side, and it's always sitting right across from that 90-degree angle. We'll call this one side C.
So where did this all come from? Well, it goes way back to an ancient Greek mathematician, Pythagoras. He figured out this amazing relationship between the sides in a super visual way. He literally pictured building squares off of each side of the triangle. And when he did that, he noticed something incredible, a pattern that just always worked, no exceptions.
And that pattern he saw, it can be boiled down to a really simple, beautiful formula, an equation so powerful it can find any missing side of any right triangle. It's pretty amazing. And here it is, the moment you've been waiting for, a squared plus b squared equals c squared. This right here is the Pythagorean Theorem. All it really means is that if you take the area of that square on leg A and add it to the area of the square on leg B, it will always be the exact same as the area of the big square on the hypotenuse, C. Okay, so let's just make sure we're all on the same page. A and B are the two shorter legs. And C, that's always, and I mean always, the long one, the hypotenuse. If you can remember that, you're honestly halfway to solving any problem. All right, the theory is cool and all, but let's see how this thing actually works in practice. We'll start with a super classic example, one that gives us a nice whole number for an answer. No messy decimals just yet. So let's say we have a triangle with legs that are 3 and 4 units long. First, we square the legs. 3 squared is 9, and 4 squared is 16. Simple enough. Then we add them together. 9 plus 16 is 25. The final step? Just take the square root of 25, which is 5. So the hypotenuse, our side C, has to be 5. See? It's a nice, clean process. Okay, that was pretty straightforward, right? That's how you find the longest side. But what if the situation's flipped? What if you already know the length of the hypotenuse, but you're missing one of the shorter legs? This happens all the time, by the way. You might know the long diagonal side C and maybe one of the legs, A, but you need to figure out that other leg, B. Don't worry, the logic is almost the same. You just have to think about it a little backwards. All right, this is the key takeaway, so listen up. If you're trying to find the longest side, the hypotenuse, you add the squares. But if you're trying to find one of the shorter legs, you subtract. And you always subtract the smaller number from the bigger one, of course. Just remember, longest side, add. Shorter side, subtract. Get that down and you'll nail it every time.
Let's test this out. We'll use the same numbers from before, just in reverse. So we know the hypotenuse is 5 and one leg is 3. We do the same steps, but we subtract instead of add. We square them, 25 and 9. Then we subtract. 25 minus 9 is 16. Finally, the square root of 16 is 4. And there you have it. We found our missing leg. It works perfectly.
Okay, we've got the tools. We know how to use the formula forwards to find the long side and backwards to find a short side. I think it's time. Let's go back to that ladder problem from the very beginning. So here we are again, 40-foot ladder, 30-foot building. That ladder leaning against the wall with the ground underneath, what does that make? It's a perfect right triangle, hiding in plain sight. Can you see it now? Let's break this down. The ladder itself, that's the longest side, right? So that's our hypotenuse, C. The building is one of the straight sides, so that's a leg, A. We're looking for the distance on the ground, which is the other leg. And since we're looking for a leg, what do? We subtract. So we square 40 and 30, subtract the smaller from the larger, and then take the square root of whatever's left. And the answer is about 26.46 feet. That's how far the ladder is from the building. Isn't that cool? It's just a perfect example of how this 2,500-year-old idea can solve a totally modern, real-world problem.
Now that you've seen it work, you're going to start seeing these triangles everywhere. I'm serious. This isn't just some dusty old math formula. These right triangles are literally hiding in plain sight all around you.
Think about it. When you buy a TV and it says it's 55 inches, what are they measuring? They're measuring the diagonal. That's the hypotenuse. So you could use this theorem to figure out the actual height and width of the screen. It's used for everything from supporting towers with wires to figuring out how high your kite is. It always comes back to that same simple formula. And really, that's the true power here. This was never just about memorizing a squared plus b squared equals c squared. It's about learning to see the world in a new way. Once you know how to spot a right triangle, you suddenly have this incredible power to measure things that are impossible to reach. So here's my challenge to you. As you go about your day today, just look around. Look at the shadow a pole casts. Look at a wheelchair ramp or the path someone takes cutting across a grassy corner. What right triangles are you going to find? And what mysteries can you now solve?